and welcome to another day of Odin's Day. Yes. Yes, we're just going to wait till everything gets started before I start hit record and such. Just making sure everything is actually streaming correctly. Right, hello, and welcome everybody. Good. I'm just going to post the link to all of the particular places, as you know. That's what we do on these streams. So we need to put them in that place, that place, that place, that place. I've got a lot of places to put them, if you didn't guess. Probably should just make a script or something that automates it to put it everywhere you like. So I'm just going to retweet the actual thing itself. Okay, I'm going to wait for a little bit longer. I'm going to have a drink of this lovely water, and then we're going to start the stream very soon. So hopefully everything can go well. Right. So people, hello and welcome to the stream. I am going to be changing over to a different thing in a very brief moment. Yes, be excited. Be excited is what I'm about to say. Okay, I'm live with sound. Yes, so I am going to... Hello, welcome again. This is it, we're live on time. I'm just going to wait another minute or so for people to joke. And yes, Slowpoke, thank you. Yes, he is. Hello, welcome. Right. You're going to see something special. Get ready, guys. Get ready. 3, 2, 1. Hello. How are you doing, guys? Welcome to the stream. It is now Odin's Day, and I have actually bothered to hook up a camera for once. Yep, that's what I'm doing. So that's pretty cool, or what? A camera. I can see you. Yeah. I know. I am Ginger, with the ginger beard, with the Odin shirt as well. Yes, everything is glorious today for this stream. So we want to make sure everything was top-notch when we're doing it, but hey, now you can see me, and I feel like a real Twitch streamer now, because you can see my face as I do things like that. But hey-ho, but today's stream will actually looking at the Odin compiler, and specifically how I have multi-threaded the entirety of the front end. And technically I've also multi-threaded the back end too. But the back end multi-threading is still highly experimental. Yes, the mustache has grown a lot well now. It's everything's grown in properly, and I have trimmed back a lot because before I was looking kind of like an Orthodox priest. So it's very big. But now I think it's better now. Yes, tonight's drink is, again, Council Pop, high quality there. It is dihydrogen monoxide, as also known as. Very good stuff. So, shall we get on with the stream for everybody who wants to know? So, for people who are known recently for, I would say this week and a couple of weeks back as well, I've been working on multi-threading the entirety of the Odin front end. And what I mean by that is trying to make sure things that can be multi-threaded, multi-thread them, if possible. This doesn't mean I have optimized the code heavily, just in general that it is being prepared so we don't actually have serial bottlenecks in the language itself. So trying to think this through, in here I have sectioned out most of the code. And as you can probably see in this code here, they're all a little sectioned out, and we've got the different timing sections. So before I do anything, just to prove it, when I run this code, it's going to run the Odin demo, and it's going to be a bit slower than normal because I'm on a stream, and when I'm on a stream, the CPUs get slow because OBS takes a lot, the video encoding takes up a lot, and also uploading it to my internet just takes up a lot. So Usually things are a bit slower, about 50% to 100% slower, which is fine for a stream. But there's the thing. I took measurements before I did the stream to show you whereabouts it is. I still had OBS open, so it was still actually a bit slow, but still. Should have been a bit more prepared there. But yes, let's carry on. So this is just showing the Odin build, and I'm going to flip over to Odin show more timings. And this is going to be a breakdown of all of the timings within the front end. So Odin check is the wonderful command in Odin, which will check your Odin program without building it. This is very, very useful in Odin so that you can type check your system without having to compile it again, which sounds a bit, but it means you can hook it up to your text editor or so what, and it'll be very, very quick usually. Again, I'm running on a stream. This is usually below 100 milliseconds anyway, but that is the whole demo, which is quite a big, got a lot of files. In fact, if I remember correctly, I've got all the BD information. That is 99 files. The total file sizes I've got here is a megabyte of data in total. And it tells you all of the parsing stuff I've got on there as well. So that's pretty good. So let's break this down for each section of the front end, because that's what the front end is, the Odin check. The middle end would be the intermediate representation generation. And then the back end would be the code generation. So to keep it simple, we're going to call it the front end and the back end. So the front end is the semantic checking, the tokenizing, parsing, and semantic checking. The back end is the code generation, so lowering that AST into machine code. Okay, hopefully that is clear to everybody. And if you've got any questions, please ask in the Twitch chat. I will answer them. There's also, you can ask on the Odin Discord, where we have the stream chat open as well. Okay. That's good. So let's break down parts of the compiler. We're doing a little bit of a compiler run through here. And I'm just going to go through the parser. So the first stage is we have the parser stage effectively. And what the parser does is it loads up some initial files. The first file the first files will be the first package that you pass to it. So in this case, we're doing the demo package. And the demo package has one file in it, so it's going to pass that file. It also will require that we pass there's a runtime package going in there as well, which is a collection of multiple files that are needed by the runtime. Again, the runtime is it's mostly for bootstrapping and some minimal things, like for instance, again, bootstrapping purposes. It made things a little bit easier. So that's okay. And then it goes through. So the way it works is you've got a nice little worker queue going off within a thread pool, and each thread will tokenize and parse a file. So that's what each worker does. Very simple. And each worker, when it goes through, it looks at the import declarations that it's parsing and says, okay, search up that thing and add that to a queue to be done if it's not already been checked before. That's how it does that. And it's very basic. This thing has been multi-threaded for quite a while, actually a few years, because it's the most simplest thing to multi-thread, because none of the files, when you parse them, require a symbol table, unlike C. This means they can be parsed idempotently without any other things going on there, if that makes any sense. Okay, great. We have now got that thing. So then the parsing's very good and that's the trivial bit to multi-thread. The meat and potatoes of all of this is multi-threading the semantic checker. And the semantic checker is the hard bit. So the reason why it's hard is because you have to have a strategy how you're going to multi-thread it. And not all languages are actually capable to be multi-threaded. C is a good example of this. With C, you must parse from top down, because C can be parsed in a single pass. You can actually compile the entire language in a single pass if you wanted to. So did many other languages back in the past. Nowadays, many of them are multi-pass nowadays. They're not single pass anymore, or two pass. But yeah. Oh, hello, welcome, Per. Welcome to the stream. Do you have any interning in the multi-threaded front end, or is all deferred to the symbol table look up later? Yes, it is all deferred later. It's not because I cannot yet. It's because I've been trying to keep the stages as separate as possible, so you can tokenize and parse and type check and do the code compilation, and you're just keeping it as you go along. I'll explain the entire thing for the semantic checker as I go along. It's a very simple process. You'll think, oh, that's simple how you've done it. I'm like, yeah, but it was getting it to work the way I work, because there's certain tricks in there that I have to worry. So let's do the check parse files procedure. This is very simple in Odin. The first thing we do, on the very first thing, that's just adding some type information. We always have the invalid. It just means the type ID of 0 is 0. That's all that does. Pretty simple. Again, welcome to the stream, Per. Love to see you. As we go through all the packages, the first thing we do here is we create a scope for every single package. And then we add the packages that we've created to the map, which is just a hash, literally just we get the full path of it. I think it's just a map, string map, very simple. We also had some information, for instance, is it the initial scope we add to it or the runtime scope? And we can initialize it there. Again, the next little thing here is called the file scopes, which is very simple. We go through all the procedures and create scopes for each of the files. One thing we do here is we figure out the total possible package declarations that we could have and initialize that for the export entity queue. Now I'll explain what the exported entity queue is later. This is due to the export semantics for entities and how packages work in Odin. So for people who don't know and are new to the stream, packages in Odin are very, say, modular, Oberon, Go-like. So Go is probably the most common nowadays. As in there are packages. Packages are a directory which contains Odin files. And those Odin files have declarations in them, which I call entities. And those entities then may be exported into the package scope, which then when you import a package, you can then get them. Not all entities are, but many are. So that's what the export queue is for, because that's where the multi-threading pops in. You have to make sure you do it in 2 different stages. That's just to make sure you don't have mutex effectively. So the first stage is collecting all of the entities. So when you have a file, let's just say we've got the demo file here, which is just the demo.odin. In here, we have different entities. For instance, these imports will produce an import name, which will be an entity. These are all entities. The declarations here, these are entities. These are all the global entities we are collecting. So anything that's like a declaration here is a global entity. If we went into the runtime, let's say core, there's a type declaration here, different type declarations. There are other things like this, like static asserts. There are other forms of pseudo declarations. I call these directives. They are entities in this case. It's how the compiler works. It's just a bit of a hack, but it works absolutely fine. You'll see the logic, but everything gets handled like, okay, foreign declarations, everything is handled like that. So that's collecting it. And if you go through the collecting, we actually find that I've just got a helper function that says check with workers, and I pass this procedure to it, which is here. And what it does is it goes through the entire, it gets your threaded data, you get the checker. We got a checker context here, which we have created here just for this specifically. So a checker context is the context. So if we want to know the stuff specifically, checker context, this is have information about what you're doing as you're type checking as you go along. This can store, it's like a little intermediary thing that helps us do things. Like for instance, it'll have type hints in there. What's the state of the actual checking at the moment? For instance, checking for type cycles as well and such as well. It also has this other thing going on as well. Is the autofocus really bad? I may have to just turn the autofocus off if I know how to do that. Is it just going or I guess, yeah, it is by the looks of it. I'm going to zoom out and hopefully you're now just seeing a bit more. And my guitar's on the left. Yes, I have guitars. Ready. There we go. So there you go. It's a little bit more wide now and probably helping the autofocus there. Anyway, it's a new camera. I'm still learning how to use this camera. It's fun. Nice thing. It's very good quality at least. And very quite clear. But there you go. Hopefully that's much better and wide. Yeah, we've gone to a 16mm because it's a zoom lens, 16 to 50. But yeah, I'm getting distracted. So going back to the Odin checker, but that's fine. It's just a little intermediary thing. In this Odin checker, there is, this is again, all of it's safe to use. So each worker queue gets its own untyped map. This untyped system is for how the untyped system works in Odin. It's effectively that it's trying to patch and find out the best type it can have. So it's doing a patching system and updates as it goes along. It's just so you can have a bidirectional type inference. The rules aren't actually that difficult. This just helps with things out. And then what we do afterwards is once you've got that, you add them all to the global queue, which can be handled later. So what this does is it goes through each file. We get a file from the offset and the thing it's patched us to, and we get a file. And when we collect entities from that file, very simply, if we go look to the collect entities, we go through all of the declarations. So the first thing is if we have a when statement, which is a compile time if statement Odin, we handle them later. They're delayed and they have to be delayed because you want to make sure we've got a deterministic order, but don't worry. This is value declaration. So like these are variables, these are going to be constants, type declarations, anything that's got a value to it effectively. So it's a name and a value. That's a value declaration. The other one we have are import declarations. Yeah, this is I just need to get rid of the to-do, they're old comments, is import declarations. These get delayed because we evaluate them after everything else. It's how to do the collection. It is very important that we do these different times because when we collect one, we also evaluate at the exact same time. That's how imports work. It's to get around a race condition, really, pretty much. And it also makes it more deterministic. Foreign imports, we can just import straight away, there's no problem. Foreign declarations, it goes to a foreign declaration box and collects more entities within that block, as we've just done. If we weren't at the file scope, we could then evaluate the when statements now, but we're not. We have to delay them afterwards. So that's very simple. We're just collecting the entities, and if you look at what a collecting of an entity looks like, just be very careful. First we go through the attributes to see if it's anything special, like if it's private or not, but it doesn't matter for the time being. If it's mutable, what we do is we collect all of the names, get the names, generate an entity for that name, and then just figure out any of the information on it. If it's associated with the foreign declaration, just add all the information to it, and then add that entity and the declaration information for this to the thing. So, okay, welcome to the stream, Sky Terrace. Yes, I'm just explaining how the multi-threading of the Odin frontend is working. So first stage, just the basic part was collecting the entities for each file within the packages. And we do that. Similar with all the constants. And when you go through it, we figure out, is this a type? Is this a procedure literal? Is this a procedure group? Or is it just a general constant? Then we can pass it through. And it does all of the other specific things as we go along. Okay, quite simple. Nothing out of the ordinary. So that's collecting all of the entities. It just adds them all into each file's hash map, for the string map, the scope, effectively each scope. And then once you've collected all the entities, we need to export those entities. Okay? So when we export entities, this is multi-threaded as well, luckily. We go to the export entities procedure here. And what we're doing is we're going to find all of the entities which are exported. Yes, right. I'm just making sure I'm doing the right order. And add them to the parent scope. That's all that effectively does. It's pretty simple. There's nothing really fancy going on there. So the reason why we don't add them whilst we're in the loop is because we do have to use either a concurrent hash table, which is not a very good idea necessarily for speed. You can do it, but I don't have to have a mutex to regrow all the time. I can figure out when things are to do correctly. Or the other way is you delay adding it all into a big queue, and when it is in the big queue for that package, we just set them all as when we go each time. And that means we just keep distributing the load for all of the threads. Pretty simple. Getting it good. So the next thing, which is the most complicated bit, not the most complicated, it's the first complicated bit, I should say. Now it's the first complicated bit, which is the import entities. So you know when we had import declarations within our procedures, within our files, we have to deal with them in a very specific way. So the first thing that we need to do is we need to sort the packages and how they work in the import graph. This is you create a priority queue here, and effectively you're doing a very basic, it's kind of topological sort, but is a topological sort from this priority queue. And this is determining which is the correct order for evaluation for the imports from the import graph, and which one you should be ordering first. For instance, yes, the runtime package should be ordered first, and then you figure out from that, because everything imports the runtime package, and then, because it doesn't import anything, and then you work your way through it as it works through the graph as you go through. And it just figures out what it is, and it also figures out if there's any cycles in your importations as well. And it will go, oh, we have found a cycle here. That means X refers to Y, X refers to B refers to A, or something like that. So we don't allow cycles in Odin. The reason I don't want to allow cycles in Odin is then I couldn't multi-thread. That's actually one of the things. We need to make sure that we have a tree and not a graph. That's kind of very important for when we're doing the thing. Otherwise, things do not become deterministic anymore correctly for how I need to do some of this stuff. So that's very important as well. And also another reason why I don't like cyclic imports as well is because when you're refactoring code, if you have cyclic imports, sometimes you don't realize what you depend on. And actually, for what you thought of 5 separate packages, well, just one giant one because they're all interdependent with each other. That's kind of the reason why I made a package system in Odin, because I kind of wanted to flatten the hierarchy as much as I possibly can to get rid of those unnecessary hierarchies. Some hierarchies will naturally form, of course, they are naturally occurring in nature, but this one, some people add them artificially, and again, it's usually the problem with anything. It's usually the general critique of OOP as well, isn't it? But that's just a general overview. So once we've now figured out the package order, we now need to collect the file declarations. So what do I mean by collecting the file declarations? So what we need to do is we know those delayed imports that we had. Well, we're now going to add them to each file. So we got the order of the package, and then we're going in the order of the files. So the files go in alphabetical order. That's pretty simple, isn't it? Yeah. So alphabetical for the orders, for the files, because then you've got deterministic order. So then we collect all those entities off our queue and then read them. So again, this is all single thread, unfortunately, but it's pretty fast at least. And then once we have imported them, we then go check the file declarations. And what we're checking there is we want to check for any when statements. So when we go into a when statement, like here, so this is within the code here, it gets into a when statement and goes, okay, we need to evaluate. Has this been evaluated yet? Yes or no? Okay, we need to evaluate the condition. Make sure it's a Boolean and it's fine. And if it's been determined and set it to whatever the value was for that thing. So deterministic order means you evaluate, if you have 2 when statements, let's just write some pseudocode for you. Thanks, a very good question. Thank you, Olive Prist. If you had this, like that, and then we did that, yeah, we have to define order, because if we try to evaluate this one first, this won't work. So in Odin, by the way, all declarations at the file scope are out of order. So you could actually do this. You could evaluate it completely out of order. So if you wanted to evaluate Y, then X is already found that does that. That is fine in Odin. It's very, very useful. But for when you have when statements, unfortunately, you cannot really evaluate it out of order, because you could be creating new entities which another when statement would depend on. So the rule that I've decided on is just evaluate in order, literally alphabetical order of the files from your sorted packages, and then top down. So if you have 2 when statements, like for instance, this has a condition A, which will say that A is true. This is by the way, if this A was false, this would be a bug. But the reason why it does that is because it makes a lot of sense. So you get to this A when here, you then collect all these entities, and then you start again from the top of the file. And you work your way down, you evaluate it, it's fine. There's nothing that's been created new. You then get to this, you add all the entities, and you start back to the top of the file, and you go through again. So you may think, oh, you're doing loads of checks and everything. It's like, yeah, but you've got a list of what when statements are left. So you just go through the list of the when statements, and it's pretty fast. So it's not actually necessarily, even if you're iterating across all of them, it's very quick as well, because you're just checking each node in the AST, checking what the kind is, and it's very, very, very quick. It's just loading is very quick in that regard. I can optimize things there as well, but that's for future build to worry about, those specific optimizations. I just tried to make sure I could get the multi-threading working in Odin. The logic was sound. I hope that's answered your question. So yeah, we're going through all of that, and it does all it does that you do correctly. You could also have another one here where X is then equal to, I don't know, that. And then, oh, I should just doing that as to negative 123. And then this wouldn't be defined, whatever. Okay. Makes sense. So that's when you're collecting the file decals. So, oops, collect, where are we back to? Here. So if something was added, why do you have to go back to the top? Because the problem is, and this may sound weird, like why do I have to go back to the top and not just carry on, is because it's the out of order nature of it all. I just go back to the file anyway. It's because if you've then added something here, something in a previous thing could actually depend on it. Yes, it sounds a bit weird. It's because you may be because something could get evaluated, I need to make sure that that has been added already. I know it's a little bit weird, but it is how the logic works. You could improve it. That's a good question. It's just I'd have to change the rules of the deterministic rules. I could change them to make that work, by the way. I'm just not sure if it's necessarily a good idea or intuitive. If that's clear. Okay. Okay, good. Okay, so once we then collected a file, we then get all of the untyped expressions and then just collect them up and add them to the big queue to handle them later. Make sense? Yeah. So I know they didn't really answer your question specifically. Sorry, Mikkel, but hopefully I can at a later day because it is a little bit more complicated. There's a lot to go through. Don't want to spend the entire night. Okay, then the last thing we do is we collect all of the rest of the delayed entities. These are any of the other imports that were not checked. And then the other things were any of the expressions here. So these expressions are like static, like for instance, static asserts or static panics or anything like that of that sort. Any directives that were called at the file scope which we want to check. And again, these are just, again, this single file is serial. It's not multi-threaded. It's not multi-threaded because you do need to follow it in a certain order. And if you do one thing before the other, it doesn't really work out. There are strategies, of course, to do the multi-threading for that, but I've now sped this up fast enough. I'm not that worried. It's not a bottleneck in the compiler anymore. This used to be a big bottleneck. It used to be, I've got it down about an order of magnitude faster now, which is good. I could probably get it a little bit faster as well, but I'm happy enough for the time being without just doing general optimizations. So once we've then checked the import of the entities, we need to make sure that any of the entities we've now collected, we export them again, because just in case we didn't export them when we did it. Because you could be thinking something else depends on that. So it's an order of the operations of what you're doing. So anything that was collected that wasn't exported, we need to make sure they've got exported as well. Hopefully that makes sense. So the next thing that we do is add the entities from the packages, which is, what does this mean? So this is very simple. We had a big queue of all of the entities that we had left from the entity queue, and we just need to add this to the big array. So in the checker info table, which is the checker info is effectively all the information that we need. Sorry, nope, wrong file, wrong shortcut. Checker info is all the information about kind of the program itself, other than that's on the AST directly. This information about the files, the packages, the variable initialization order, different packages in here, minimum dependency sets, definitions, entities, required foreign imports through force, and then any of the other intermediary queues that we are using whilst type checking. This could have been actually a separate structure, but I thought I'd just dump it in here as well. It's not really an issue. There's many there that we have to worry about. Yes, there's a lot of mutexes in certain cases, but a lot of queues as well, because queues. It's like post. I mean, queues. I don't know. Who is going to get that reference? I'll be impressed. But yeah, that's what that's doing there. So again, just taking a queue, putting it into an array. Take a queue, put it into an array. So now we've done all of that. We then have to check all of the global entities out there. So we type check it. So Odin isn't a lazily type checked language. So I do not confuse get with Haskell, which is lazy evaluated at runtime. I mean, at compile time, we are making sure everything is being type checked. And because of that, we need to make sure that things are working as expected, of course. And I don't really, I know there's some languages I can think of, won't say their names, where they do, the languages do a lazy type checking, so they don't check things that don't get used. They start from like one thing and it checks the things that thing uses. And if the thing doesn't get used, it doesn't get checked. The reason why I check everything is because I want to be able to multi-thread things necessarily, and also because I think usually that's more bug-like. It's very dynamic languagey to me, and the way that you get around that problem in dynamic languages is you just write a lot of tests, which just calls them to make sure they're running correctly, which is what some of the languages do as well. They have tests and then they check them in the test, not check them in the main program. So yeah, you've done a thing. You can see the benefits of both of them, obviously, but if you do lazy evaluation that way, lazy type checking should be very clear, you cannot do the trick that I'm about to do with the multi-threading. So we then go and check all of the global entities, and this has to be single-threaded. Unfortunately, he made a comment, this must be single-threaded. Don't bother trying. The reason why is you cannot know when you type, let's say you type check an entity, and a good example of this was, let's just write this. Let's take this as an example. Let's make this go. No, why did I go? Let's take Odin, for example. And we have an int in there, and then we have a pointer to bar. Okay? And then we have bar. And then it has, I don't know, a float in there. And then it has another pointer to foo in there. Now notice that foo kind of depends on bar, and bar depends on foo. Now, the way that this works, this would be fine. Now, if one was embedded inside the other, and you had this, if one got type checked before the other, and you would have to store mutex effectively, and you'd mutex it and go, oh, something's gone wrong. The other problem is if you have a cycle going on, the way that I've set up the compiler, but it's also not a bad way of doing it in general, is you want to make sure, when you're evaluating the compiler and the type checking, I do it with the checker info, and I just want to keep it dumb when it does things, and it's easy to do the error evaluation there. So it's very simple. You just go through things and you just check them as if you were a single thread. If you would try and do them multi-threaded, you would have to have loads of mutexes, and in theory, and I think it would happen in practice as well, you'd have loads of places of contention, and it wouldn't be any faster than single-threaded in practice. There are ways of improving this, and the trick is just don't do it. So you do lazy type checking, which Odin does have an internal way of doing that, by the way. I'm not advertising it. I'm not telling you how to do it. But it does allow you, for instance, if you've got like a 1,000,000-line file or something and you just want it not to be checked, then yeah, sure, just put that special thing in there. And that's what I'm going to be showing later with the Win32 API. You'll be seeing this later, don't worry. So that's very simple. We're getting about halfway through, by the way. The next thing is initting the preload. This is effectively the bootstrapping. So if it hasn't been bootstrapped halfway through when it was checking all the global entities, we need to bootstrap it now. It's very unlikely it hasn't, but so bootstrapping in this place is the runtime. So if I go to runtime core, there are things built in, for instance, the type information. That is not technically needed by anything, but yes, but the type ID is, for instance, source code location, that data structure is. Again, I could have wrote this in the compiler, but I wrote it in the code because it's easier to bootstrap and it's also self-documents. The allocator definition as well. What is an allocator? And it has all the different aspects to it. What is the context as well? Like, what's the definition of a context? Very simple, very small here. It's very useful. What are the internal memory layouts for the different data types? Like, what's a string, a slice, a dynamic array, and a raw map? The map implementation, just gone on my tangent. I've done it this way. The hash things and the entries are separate, just because then you can easily iterate on the entries. I may define it like it's not necessarily the best implementation or the fastest one, but it's very, very useful. I found it very. It also allows you technically to extend it to be a multi-map, but let's not go down that rabbit hole for the time being. But yeah, this is pretty much all of the bootstrapping stuff, if necessary, which is okay. The next thing is then we're just going to add all of the untyped expressions that we didn't add them back to the queue, and we can then add them later on, which we're going to check here. So then what we're going to do is we're going to check the procedure bodies. This is the other stage of the multi-threading. So the first bit of multi-threading we had was collect all the file entities. That's the first bit of multi-threading. The next bit of multi-threading that we've done this, so this is all single-threaded, unfortunately, but it's kind of necessary in a certain case. So the next thing is the checking procedure bodies. So if we go to check procedure bodies, we have this big old worker queue system. Yes, it's probably not the most elegant written code, but it works quite well. And what you're doing is you're divvying up all of the different procedures. So I notice this here, it distributes the work. So you go one to one worker, one to the other. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Rather than go 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3. The reason for this is that it's more likely to be a better distribution for the workload for what it needs to be done. So it's then adding the procedure bodies for what we're doing. So what do I mean by this? In Odin, when you look at a procedure, let's actually look at the demo rather than the core, because that's just not going to be very clear. Let's look at the demo. And look at this procedure here, the union type. In Odin, the procedure signature, which is this thing here, which is the type of the procedure. It could have had parameters in here, could have had a return value, could have had multiple return values, I don't know, and they could have been named or something as well, whatever. This is evaluated before the body is. And the reason for this is I wanted it when you were calling it, you could then delay the body and check that later, which could be on another thread, which is the kind of the whole idea. And this is therefore you can just work on the signatures alone. This is very simple. You could say the header and the body are separate, or the prototype and the body are separate as well. Another way, like in C, you have prototypes of the headers, and then the body of the procedures defined elsewhere. So it is already split up beforehand. So when you actually check those global entities, the procedure bodies get added to a queue, and the queue that they get added to is whereabouts is it? Not the check context here. Not procedures. Procedures to check queue. Isn't that right? It's called. It's a proc body. Procedures to check queue, and there's also a nice little semaphore next to it is there. So they get delayed. We get the signatures evaluated, but not the bodies. It's the same how the parapoly, the generics in language, the parametric polymorphism in the language works. Things get worked delayed. So if I just undo all this, the signature gets evaluated and the body gets later. So now that all the bodies are delayed, they don't get checked until the parent scope is done. So that's why we wanted to check all the entities first and then do the bodies. Because then, if everything else is checked in the global scope, the global scope, the body of a procedure only has to read the memory. It's going to be read-only memory now. So these maps don't have a mutex on them because they're completely read-only, which is the lovely thing about it. It will just work in that case. So you can just read it. Okay, fine, lookup, done. In that sense. Okay, so that's very simple. You just divvy it up, and here's like the procedure body data. And in each worker will have its own queue, which it pulls off and consumes the body. Now, very simple, makes sense. Now, another caveat in Odin is that Odin actually allows for nested procedures. You can define a procedure in a procedure like this. Like, oh, I've defined a procedure within this procedure, and this is just normal. Like, it's the same. It works the same as if I just dragged it out there. They're not closures in Odin. They are just procedures. Okay, so it's not a silly question, so thank you, Duke Flops. So the question is maybe a silly question. No, it's not. Does Odin have any form of metaprogramming? Odin does not have like compile time evaluation like C++, or Jonathan Blow's language. It doesn't also have a AST modification like a Lisp or stuff. I didn't want the reason why. Very careful. Odin does have like runtime type evaluation, so reflection. I actually call reflection a form of metaprogramming because you're writing a program that it reads its own program, so you can analyze the program, even generate a program. The goal for Odin as well for metaprogramming is purely to have the Odin compiler be just a packaging core. So you can literally import the compiler, modify it to however you wish, intercept it, do whatever you need, and write your own metaprogrammer. There's two reasons why I want to do. Actually, no, 3 reasons why I do this. 3 reasons. The first is I don't believe most people should be doing metaprogramming because it's really difficult to do right. Not just like in the language, but I mean like actually using it. And even experienced programmers like myself will cock up a lot. The second thing is you don't want it on a package level. Like for instance, if you have a third-party code, I don't really want to rely on its metaprogramming abilities. I want to make sure that the thing itself is kind of free from metaprogramming. This helps me to integrate it into my code base. Some people would argue, no, that'll help you integrate it. I'm like, I just want it dumb. Like, trust me, dumber is better than smart, is one case. The third thing is the reason why is you cannot please everybody with metaprogramming. As in, what you want from the language may be something different what you want. You may want to add something else. And effectively, if you just allow people to have the compiler, modify it at their own wish, they can make their own, effectively a dialect of Odin to make their own metaprogramming. Because that's what many people do. And it's kind of what you need to do in an imperative language, of course, an imperative procedural language. There are other languages out there that do nice metaprogramming and such, but Odin is not trying to be one of them. It's trying to be, again, a C alternative and such like that. Odin doesn't also have macros in the language because this may sound bizarre. I have not needed macros at all, really, for Odin in the 5 years now that I started Odin. It's been about 5 years ago since I started it, which is surprising. I would have kept thinking, I'm going to need to add macros soon. I'm going to have to add macros soon. And when the opportunity came up, I was like, I could just add this feature, the specific feature that I actually needed. And usually it was through the attribute system, or it was just a new feature. And I was like, oh, that's even better, more elegant, and it's more common of a case than you can. And then when I actually get to the general case, like, oh, I never needed it. Or if I did need code generation, I just wrote the program to write the code, and I just was done. So I hope that was clearing up. I will get back to what now people got all lost on track. I was explaining the multi-threading process for the procedure bodies. So the procedure bodies are delayed in their evaluation. So the signature, as I said, gets evaluated before the body, and the body gets added to a queue, which then a worker in a thread pool effectively picks up later. Now, one of the interesting things in Odin is that it has nested procedures. These aren't closures; they're just bog standard procedures, and you could copy this to the global scope and it would still work. It's very useful for when you're doing local things. Like you want to actually have a reuser procedure, but you just want it local to thing. You don't want to have it exported, nor do you want it to. It's better to have it there. You think locally, effectively. But the problem is then, okay, we've added this body. These bodies need to get delayed. So the way it works is, this is the reason why this is a multiple producer, multiple consumer queue, is because it itself is adding to the queue. It isn't just reading from the queue, it's also writing to the queue. So in that case, you have to be careful. And it was from other things as well, but that's the reason why I can't. So technically, it's no, it is, yeah, because it's technically in multiple places. It could technically, no, I'll keep it. It makes sense to be there because also like the queue implementation is very simple. I could always explain how the queue thing works later, but not for now. That's always nice. I'm going to be on tangents. So that's how that works. And the way I've done it, I actually did experiment with other approaches previously, but for the time being, I've kept it simple. Is that so when a procedure is dependent on another procedure whose body hasn't been read, what happens? Brilliant question. I was just about to answer that. Here is the consume proc info queue. So a procedure only depends on its parent's body, which could be the file scope or it could be another procedure scope. And this is very, very simple. You check to see if the parent scope has been checked yet. If it hasn't been checked yet, just add it back to the end of the queue and check it later. So again, only check a nested procedure if its parent's body has been checked first. This is to prevent any possible race conditions in evaluation when multi-threaded. Note, in single-threaded mode, this should never happen, and it doesn't. But that's all it does. So it was a brilliant question, Eater Energy. So that's what happens. So the only thing a procedure body could depend on is its parent. And if its parent has been checked, then it's fine. That's all it needs to do. That's why, effectively, you've got single-threaded everywhere still, but it's in a hierarchy of how it's going. Each worker is fine. Every worker is only dependent on itself. It's all isolated. Hopefully that makes more sense now. Okay? So that's kind of how that procedure thing works. And you can see it's going through, it's churning through, and everything should be A-okay. That's great, isn't it? So we're scrolling down now, and where was it to? We got there. So that's checking all the procedure bodies. The next one is we need to find wherever the procedure body is picked up. Any more entities, we can add it to the big queue. So the big queue is the entities, the entity list. We want a big list of all the possible entities that ever got defined, so we can iterate across them when we do the build system. It's very easier. The next little thing I do here is just single-threaded. This could be completely multi-threaded. There is no reason it cannot be, but it is so fast, there's no real need. This is just checking, for the time being at least, because if you look at the timings that I wrote for that section, check scope usage, that's 40 microseconds. I don't think I need to optimize that yet. I think it's fast enough. Yeah, but what it's doing is the scope checking is for stuff like vet. So vet is a thing in Odin, it's a flag in Odin -vet, and checks many things. Like for instance, it will sort the entities in the things that need to be vetted. It's checking for things that are entities that are unused or entities that have a possible shadowing to them. If they're unused, it will tell you it's unused. If it's shadowed, it says where it's being shadowed and where it's being shadowed from. It could be shadowing just a normal variable or shadowing something that was through using. That's very useful there. This is, that's just possibility. You could have a Stack Overflow. This is just to say, if you've got a variable on the stack, which is greater than 128 kilobytes, is that right? 128 kilobytes. It's possibly a Stack Overflow. Now that may sound, isn't your stack usually 4 or 8 megabytes normally? Yes. But this is actually a way of getting around a bug in LLVM. LLVM doesn't like big data types at all. And I found empirically over that, it really likes to cock up. And it's like, even though there is no reason why it couldn't do that, just LLVM just doesn't like it. So that's the reason why I kind of put that in there. Great. But it helped with a few people anyway. That's what were some Stack Overflows caused by LLVM, not caused by Odin. But yeah, that was what that is. So scope, that's fine. Single thread didn't need to be. The minimum dependency system is still single threaded, but it's pretty fast, so it's not a problem. So the minimum dependency system is it goes from the main procedure and anything that's exported, and then goes from the minimum dependency and whatever the exported things are, and finds out what it uses. So the whole point is that I don't compile things I don't use, effectively. That's the whole point, is if you don't use it, doesn't get compiled. And also, if you don't use something that's foreign as well, like linking against it, which is the lovely thing about the foreign entity import system in Odin, you don't link against it either. So even though you've used a foreign library, which has now got like foreign import, which is similar to like pragma lib in some compilers, C compilers, if you don't use it, you don't import it unless you're forcing it to import it like you need to. And yes, you're right. Sorry, Kalim is very true. A big struct will make LLVM compile like 10 times slower. It seems to be some very, can't think of the right word. Makes LLVM go a bit crazy, effectively. That's what's going on. And you don't want to make LLVM mad, because otherwise your compile times go fast. And it's already pretty fast. They go very, very slow, sorry. And LLVM is already slow, like very slow. You'll see why in a minute when I compile. The next thing is you're checking any of the test procedures. So test procedures are, if you're in test mode, like you do an Odin test rather than Odin run or Odin check or Odin build, it'll check the bodies of them as well and make sure that they are all collected and then can be added to a big array, so you can add them into to be called later, into your test runner, which is again just looks through a queue and runs the test runner for you. The next thing is the global initialization order system. So you need to figure out the initialization of global variables because they are out of order. You need to figure out which way they're working. So a good example of this is, let's say we have this, right? That is absolutely fine in Odin because X will get evaluated before Y. And so you need to say X gets evaluated before Y. Very simple. You could have another one where theoretically, let's not do this. It's a bit more simpler. Foo depends on Y, so therefore X needs to be checked before Y does. So Y needs to be checked before X does. Even though I know this is constant, it could be possibly that you could do this as well. So yes, they are runtime calls at the file scope, which is like, wait, what? Like, no, it actually is very, very useful. It means you can initialize code, do it quite call, and then just done. It's a very nice thing. It's very simple. It just adds it to the main effectively, and it does that way. So that's all that does there. So you can do effectively change the order of evaluation for the global stuff. That's just very simple check. It's not that difficult. Just sorting a graph in a certain way, figuring out where things go, and checking the order. The last thing is checking any bodies that haven't been checked. So this is actually happened in single thread. It's not actually a multi-threaded problem. This is because certain things theoretically. By the way, in practice, I have never, ever, ever seen it hit it, except once. And I know what caused it. And it's because sometimes, theoretically, you could have something that was at the end of the queue, never got checked, and because it wasn't ever got checked, it needed to be in there. It was mainly in weird neurotic edge cases. Not neurotic. There's a word for it? I'm trying to look for it, but yeah, there's a weird edge case that's happening. I do not think it ever happens now in this new system. I could probably remove this code, and if I even look at the sections of this, what was the section called? Check bodies have all been typed. Check all bodies. No, to check. Where is it? Checked. Where is it? Check all bodies have checked. Yeah, is 52 microseconds. That's nothing. Esoteric? Yeah, maybe esoteric. Yeah, I can't think of the word right now. My brain's gone. Right, the global initialization order is, again, that could be multi-threaded, but I won't. If you actually want to see what it is, it's actually not simple at all. So effectively, you create your dependency graph. You then generate a priority queue from the dependency graph. Then you do the sorting of this thing. It's just a nice little basic sort for the priority queue. And that's how that works. So that's that for the global initialization order. Okay. And the minimal dependency set, I forgot, that's very simple. You just add things to a queue and you just work it through. That's people very simple to do. There are certain things that have to be required. Half of these are for LLVM, half of them, like those are for LLVM, unfortunately. Again, LLVM. But the rest are for Odin. They're absolutely fine. We go through everything it needs to do it. Yeah, you can get the gist. It's just adding things to a set. Procedures that, bodies. Did I miss anything specific? Nope, that's good news. Carry on. So, what was the big section here? Generate any dependency graph. Oh yeah, because that's fun. That's not easy, but it's only a bit of graph theory. Only a bit. Yes, so this is the untyped stuff. You remember that big global untyped queue that I said it was? Well, we're just going to pop it off as we go along. And what we're doing here is concretizing the type. So in Odin's untyped system, this is a bit more, most people don't need to worry about it because it just works. The whole point of the value system in Odin is it just works. Is a possibility that it hasn't been concretized yet. And because these ones will always still be untyped. So it's proving that these haven't been concretized. That's the whole point of these untyped. They're still untyped. And then you're asserting that they're untyped. They haven't got a well-defined type to them. And assigning that untyped type to them still. So that may sound bizarre what I've just said. But to explain it this way, you have, for instance, the very simple example is 1 plus 1. These are both untyped integers. So the type of that expression is still an untyped integer. But you could have this where that's an integer and that's an untyped float. That means the value of this now becomes, 246.123. So that's what that gets evaluated to. And then that full value of the compile time value evaluation there is now an untyped float. And it's making sure it's assigned correctly. There are also cases in Odin where there are runtime values which can be untyped. A really, really good example of this is any expression. So if I have, for instance, this expression here, for instance, x is equal to y, the type of this expression is an untyped Boolean. This means it has no determined size to it, effectively. As in, in the type checker system, there is no size to this thing. It's untyped. And this means that the backend can determine what the best Boolean type to be used. So instead of it having to be 1 byte or 1 bit or whatever the language defines, it can be anything. And this complements Odin's sized Boolean types as well. Like Odin, you can be specific about the size of the Boolean you want to use. Like you could use a B8, which is 8 bits, or B64 if you wanted to use 64 bits there. And the compiler can make that decision as well in the back end and say, okay, it's actually more efficient. Instead of just making sure it fits into a byte, we can just use a full word or full 4 bytes or whatever, and do that operation quicker. It sounds like a very minor thing, but it actually helps with some nice optimizations there. That's kind of like that. So that's the untyped value system. Again, it's meant to be magic. The rules are a bit esoteric in this case, but it's because it's trying to build it. When you're designing a language, you have to worry about how many people's intuitions actually work. And many people's intuitions aren't simple. They are bundles of complex ideas together. And one of the goals you have to remember about Odin is it's trying to have the principle of the least surprise up there. Understanding how real people program. It just telling you how real people program and how they think about these issues. So you need to figure out how to deal with those when you design. I'm not trying to enforce my worldview necessarily. I'm trying to say, okay, this is how people understand programming. This is how they have the intuitions. I'm going to build on them and design from there. And trying to make things just work like that, magic, is a lot more harder than you think when it comes to design, like design in general. But people will think, oh, this feels so good to use. And I will see learning people when you see Odin, and they'll just say, oh, it's buttery smooth to programming, or it's just so good. It just feels right. It's not trying to fight me. And it's also, it just lets me get on and solve the problems that I have. And when I hear that, it just brings a big smile to my face. It's like, oh, I did it well then in that case. Sometimes people have complaints like, oh, it doesn't work in this way. And I'm like, yeah. And the reason sometimes, like, yeah, I've done it specifically, designed it that way on purpose, because either I'm trying to get away of a habit and like, don't want you to be doing that, or it's more of a, yeah, there's an easier way of doing it, and the way you're trying to do it, it should have been done with another thing. So sometimes it's more difficult one way because it's simpler another path. And it's a very difficult thing in a design, if many people talk about that. But okay, we're now getting to the hour mark, but it's about 50 minutes of me talking at least for this. The next thing is adding all the type information. This is similar to the minimum dependency, but we're adding the type information for the types that were used. In the runtime type information, by the way, it's runtime type information. This is unfortunately slow in large projects, by the way, not slow in this small project, but in like big projects when it gets to, I don't know, 100,000 lines onwards. I call that large. 100,000 lines is large. A million's extra large, or supersized after that as well. But then it gets, this could be single multi-threaded. I haven't, because you're inserting into a hash set effectively. And when you're inserting into a hash set and a hash map at the same time, it gets a little tricky. And I know there are methods to allow this, and I will have to experiment with this. But for the time being, I'm more worried about making sure it works fine. And it works correctly. And I'd rather take the slowness there, if that makes any sense. I hope that's clear. Right, the next thing is we're just doing a double check to make sure we didn't miss any type cycles or inlining cycles. For instance, X could inline, like if you have a procedure that's inlining, we don't want to make sure it's doing anything like that. It makes other inlines possible. Like for instance, you can't inline a recursive procedure. That's what it's trying to say. Like inline in Odin is force inline. It's like you have a directive clash force inline. It's not a hint. If you try to force inline something and it's actually recursively doing it, it won't do tail recursion because it might not be possible. So it just says, don't do that. It may be nice to add another directive in the future which says must do tail call or tail recursive or whatever later, but that's a different construct to a force inline. And again, it just doesn't just check the types. It just checks to see what the alignment is. And if it just figures out the type and as it's doing the size of it says, oh, this hasn't been evaluated yet, and actually we've just found a cycle, then it's going to throw an error. This is just a very basic trick. Most of these types should be completely cached already, all the alignments, all the size, all cached, so it should be stupidly quick to check. And it is in practice. If we actually look, yes, that's half a millisecond. There are quite a lot of types, but yeah. Again, I'm only optimizing the big things, not the little things. If it's under a millisecond, I'm ignoring it for the time being. Another one is add type info to the definitions. That's pretty simple there as well. That is okay, it's not add type information is the bottleneck. Add type information to the type definitions is the bottleneck. And yes, that's the bit in large projects. At the moment, it's only about 1.8.8. But in Embergen, which is what I work at Jenga Effects, which uses Odin as the programming language. Yep, Odin, Embergen is written in Odin. And for our project, I think that hits 100 milliseconds with the thing. So it's still not slow. Well, it is slow. 100 milliseconds is a long time. That actually is, I think I remember testing that's a quarter of the entire front end. And it's like, what? It's like, yeah. So that needs to be sped up a lot. And I know how to increase the speed there. That is mainly improving the data structures. Just having more efficient data structures and having better code paths as well. And that can be, I could cut that down by a factor of, I'm trying to think in theory what we could do. 8 to 20, I'd say, in that range. The reason why I'm saying 20 and not 16 is because I think you could probably shave off in certain areas as well if you actually do some predictions. You can trick. I mean, I'm thinking about the computers, but yeah, you could probably get that done by a lot. Yeah, an order of magnitude, which is say an order of magnitude faster, which is I think is doable. So again, there's always little optimizations I can do yet. I'm just trying to make sure. This whole thing was multi-threading the front end and making sure it's all working. And then the rest is very simple. We check all the deferred procedures. So deferred procedures are a little thing where many people would have used a macro in C++ to do. So what is a deferred procedure? Do I actually have it in the demo? Yes, I do. So deferred procedures are very simple. You associate a procedure with a procedure else and it gets deferred at the end. So in this, if we looked at the demo, and we just called this demo, just this procedure call, get rid of the check and build. We have this deferred procedure, and what it's doing here is it goes call the welcome, so open, we just call it, and then it's true, so we go into the body. There's something in the middle, mate, and then this has been deferred and it's unclosed. So effectively, this is equivalent to if I did OK, open, welcome. I'm going to write the equivalent code. If OK, yeah, and then closure, OK, like so. That is what that's doing. It's doing it on deferred out, and deferred out means do it on the output. And what the checking the deferred procedure is making sure that these are valid. They can be deferred to later because this doesn't depend, the actual value doesn't depend on what the deferred thing is. And that's just added later. That's very simple. That's done single threaded. That could be multi-threaded. There's no reason it couldn't be multi-threaded. It's just in practice, it's usually very, very small. So I'm going to keep it serial for the time being until I notice it becomes a bottleneck. I don't think it'll ever be. The deferred thing is actually not even possible technically in any language I know of, actually, because mostly if you got C++ with RAI and you have a constructor approach, which is what you would do for the macro and have a constructor, is that that does defer like that to make it very clear. That's what it's doing, making sure it's a defer. Is that with RAI I have an object and it checks it here, but the problem is that you're constructing an object which isn't a Boolean, so it couldn't be used in an if statement. Like if this was just called without an if statement in there, like for instance, if this was just this, that's equivalent to me doing that. They are the same in this case. So you may be asking me, like, what is the purpose of doing this? Like, why do you want deferred entities, like deferred attributes in Odin? As some people are saying, it's really good for profiling. You just add a profiling thing at the top, which you would normally do because you have, say, begin and end, and you put a tag on there that says this is the end, and boop, it just defers it till the end of the scope. Another thing it's really, really useful for is when you're using UI, like immediate mode UIs is what we're doing in NemberGem, because we are changing the UI all the time. So it's better than doing like a retained mode. We're using the intermediate mode because it allows us also to have a lot more complex UI. And it's brilliant in there because you can have this be effectively like something that would normally have to defer a close at the end of the scope. You just have that in there. It looks beautiful, like have a nice little tree going on, and you don't have to make sure it closed. It sounds very. It's solving a particular problem which macros would have been used in certain languages, or even. And it's like, no, this is the problem. This is the pattern, and we just implement the pattern itself. Don't have this generalized tool for when you actually wanted something specific. That's kind of the idea in Odin, is don't have general tools, just don't have so general idea that can do everything with it, but it won't do it very well. Have something that's very specific and do it perfectly to how you actually wanted it. Like in Odin, we have deferred non, so it takes non the parameters, deferred in, takes the in parameters, deferred out, takes the out parameters, also deferred in out, which takes the input and the outputs. Let's go. Do you know where I could learn more about immediate mode UI? So yes, there's one of the very good lectures on it was by Casey Muratori. He was one of the first to popularize it. He didn't invent it, but he did popularize it in the 2003-ish, 2005, around that time. And a good lecture explaining how it works and how it differs from like how most people know with user interfaces which are retained mode, as they would be called. But I'm very careful. Many people make this mistake. Intermediate mode just means the code. It tells you nothing about how internals work, because the internals can look identical to a retained mode, by the way, and like it just tells you how the code interacts. That's the case. So someone's linked to it. Thank you very much. That's a very good link to watch. Okay. Hopefully this is all coming along now. Yes, there's another one which is RxI's micro UI. Yes, I work with him on Embergen in Well. He works on the team and he does the UI code. Isn't that great? So yes, if you want to check out RxI stuff, is very good, and like it's very basic, and I do recommend his stuff. And it's not just because I work for him; he's actually really good at what he does. He is really good, which is good. So we're getting to that. We're nearly at the stage that we're just finding the entry point. We know where the entry point was. It was very simple, and making sure that if there has to be an entry point, like for instance, we're in executable mode on DLL mode, we're not. And if we've not set, there's no entry point flag, we need to check the entry point. Done. If you call opening closure, does it give an error? No. Because that could theoretically be possible. Like actually theoretically possible. Which sounds a lot like, why would you want that? I don't know why you'd want that, but you can. Like it's just a recursive call at the end of the day. It's just recursion. There's nothing wrong with recursion. And then the last check that we do is making sure all the package end names in Odin are unique. So in Odin, there is this package name at the top of everything, and you think, why do these have to be unique? Like, why do they even exist in the first place? And also, it says, what does the package name have to? What does the import name? So import names have nothing to do with the package names. It's a bit bizarre, but they exist for kind of two reasons. The main reason is to have consistent ABI in the language. That means that when this procedure is added to an object file, it is going to be called main.struct_type. It will always be called that because this defines the prefix for the ABI. And that's how I wanted a way of defining consistent ABI in a language that had modules, effective packages. And many languages nowadays that have packages, they don't care about that at all. They just create one, and they only have it consistent when you explicitly export it or explicitly give it its own link name. In Odin, I said, no. It's very useful to have consistent ABI in debuggers. Like I can just type the name of the procedures. Like, oh, I want to break on the usage of that main.thebasics, and I just type it into my thing, and it just breaks on it. And I don't have to go in the source code and put the dot next to the thing where it's going to break. And it's just easier in that case. There's many, and also it's very much easier if you do analysis tools and like that. Having consistent ABI. The second thing is you can actually bind things to it. Like for instance, build tags or other operations that you can modify. Like if everything in that export thing is private or not. There's many different things that you could do. Hopefully that has cleared that thing up. And that is actually pretty much explained the entirety of the checker, and it's gone step by step. I haven't explained like how the expressions or the statements work respectively, but they're pretty obvious. If you've done a compiler before, they're pretty obvious. But that's explaining where the things are multi-threaded and which bits are not multi-threaded and which things that could be multi-threaded which are not yet. So these theoretically could, but there's no need. Again, collecting all the entities is multi-threaded because you do it on a per file basis and the workers just collect them up as they go along. Pretty simple. This one here is whatever was added to the queue. We now export them into the scope, into the parent scope. We do all the import entities and then do an export if any of them got missed, because import entities are separate, and they are separately evaluated for good reasons. The import entities like when statements, import declarations, and then we export again anything that was left. It's usually in like one or two if you've got a few when statements, not much usually. Then we're going to add all of the entities from that we collected and add them to the big queue, which is good for the back end. That's all that's for. Just how unique should it be? It's unique to your project, not unique to the file, yes. So every file within a package, so in a directory, must have the same package name. So it must have the same, sorry, I'm not even Odin. What are you talking about? I must have this at the same and everything in here. So if I go, for instance, let's just give an example of a package in Odin. Let's go to, Oh no, let's go IO. Let's go the IO package. So this file here has it, this file has it, that file has it, that file has it, that file has it. So every single one has the same package declaration at the top. And that name is unique to your project. It is not unique, it's not unique to the file. It's unique to the package. Odin has packages, and packages are made out of files. So that's the way of thinking about it. And you import a package. And again, packages aren't actually nested. They're actually completely flat. What is giving the nesting or the hierarchical nature is the file system. So for instance, a good example of this is the math stuff. In math, we have the main math library, very simple, but it has many different things in here. It has like the bits, the fixed, the linear algebra stuff, the random stuff. And in those, it's just using the file structure. But into the compiler, it doesn't care about the file structure. It just has a completely flat thing to it. And it may seem like, why is that useful? It's like, because you don't need to worry about hierarchies of importing them anymore. And you just import it as if it's just a file path. You don't need to add an extra hierarchy when you've already got one as part of the file system. So a package is always made of files from a single directory. That is correct. That is what a package is. It is very basic in that case. It will get all of the Odin files from that file, and that is your package. That's all it is. This comes from Modular or Oberon, or the more language is Go that does this. Go has this approach to packages. Many of the languages do different approaches, like Python, a file is a package. Or is it a module? I always get those two mixed up in Python. They're a bit I always forget with the terminology, but let's just call it as a package for the time being. In Python, it's a file. In C, there isn't such thing. There's just one file. It's a module. Thank you. Sorry, I always get them mixed up. But it's the same concept. It's just a word, and people use them interchangeably for the same thing in different contexts anyway. So, C++ has, in the new C++, it has modules, doesn't it? But they're also crap. So let's not go there. But they also had namespaces before. That's another way of doing thing. And you would have an explicit namespace, but you still had effectively one giant file and how things worked. That's just how the C preprocessor works. Then they're the four main categories you can have. There's a fifth one as well, but the fifth one is technically how C++ used to do it before namespaces existed. It used to have a struct, and then you define everything embedded in the struct, so using a type. That's another way of doing it. So technically that's a fifth approach. So that's how you do packages in general. So I decided doing the thing itself, but that's fine. So hopefully that makes explained and stuff. There is something else I can show off, but this is highly experimental. No, big disclaimer, if you can see, experimental. It is multi-threading the backend as well. So the backend is multi-threaded, and this is done on a per package basis because each package can be compiled separately, theoretically. This is the theoretical idea behind it. And I'm going to use separate modules for those things. A module is the LLVM conception of what a thing is. It's a module. So I'm using the LLVM stuff. So we can run. Let's do build. Don't have to run it. You don't want to see the demo every time. So this is done it multi-threaded. So if we look at the thing before and after. Okay, so this is the big code. Before, this took about 110 milliseconds. It's usually lower than this, but I'm on stream, of course. It adds about 50% again to the time, just because. If we looked at, that's build. Sorry, let's just do build. And if we do build, look how much it's added. It's added about 600 milliseconds to the build because the LLVM stage is slow, and then the linker is slow. So, in fact, the linker takes more time than the actual front end. The LLVM is twice the size in time of the linker as well, probably more than that. Like, you can see what happens. Like my code generation here. The code generation that I actually do is tiny, and then you do the function passes, the module passes, which is the optimizations. Like, okay, so code generation for the entire thing was 38 milliseconds. Nothing. That's single threaded as well. It's really easy to generate code once you've got everything checked. You just read it up and go dump. The next thing is then you're doing the optimization passes, which are slow. and I didn't want to do many of them, but you have to, unfortunately. And then you're doing all the other stuff here, and then you do the object generation here, and it generates one of the objects, which is here, and it takes a while to do. And then once it's done it, you then do the linking. Okay, simple, that's fine. So theoretically, each package could be its own module in LLVM speak, and then they could generate its own object. So if we just use separate modules as the experimental flag, it's experimental, do not use it, it's going to generate multiple of them. And you've noticed here, did it actually call that? Yeah. It's now gone from 700 to 480. And what it's done here is that, oh look, it's already gone down in time in object generation. It's like, wait, it's gone down in time. Yes, because one of the problems with LLVM is, if anyone's actually used LLVM, there are many places when it does code generation and also optimizations, which are n squared. So very simple. If you do the math in your head, I've got a piece of paper here if we want to show it. Have I got a big pen? Yeah, I've got a big pen. Oh, let's do it. We could do this on the thing. We'd actually, know what? I am going to be doing this, and you know, you have a big screen. You can see me here. What happens if you have n squared problem? Right. Here's n squared. Everybody sees this. This is really high tech now. Really high tech for my math. Now, what happens if we split it up into m modules? So, if we have, so we still got m times m, and we put it over m. Yeah, makes sense. So we've got m modules, so this is equivalent to that, is it not? Yeah, so they're still equivalent, and then we split them up. And what happens is that we've now split them up, and we square it. This will then become equivalent to, I'm just going to write it as, we split it into m modules, and guess what? This is very rough, by the way, obviously, but in your mathematics, we get the scaling factor goes down by m. So if you have m modules to deal with in LLVM, you can make it go faster by theoretical maximum of m. If it was truly n squared in every case, it's not. I know sometimes it's mostly linear, but sometimes it goes super linear. And that's a very way of breaking it down. And again, very basic mathematics there. I know it's just people could figure that out themselves, but hey, that's how you can get around a lot of the problems when you have n squared. If you can break it down, you could just reduce it linearly. So let's go back to my screen so you don't have to just see my face now in full. Oops, wrong one. Let's go to that one. Okay, so that is actually showed. So that technically means what I've just showed here is every single stage. So the tokenization stage, parsing stage, semantic checking stage, code generation stage, object generation stage, and linking stage. Theoretically, every single one could be threaded and is threaded, but they're separate. And again, the whole reason I've designed Odin is why you've got the stages separate is because then you can use different toolings on different stages. And I didn't want them to be intermingling, even though theoretically you could get even faster compile times. It then means you're designing a language a certain way, you can't use this. So yeah, sorry, I was keeping, I know the Dane didn't talk about math as being bad, but I was trying to keep it very basic. This is basic algebra that you'd probably learn it when you're like, I don't know, 10, maybe, 11, I can't remember when you started at 11. Yeah. In most schools you do it level, I think. You may learn it earlier if you did, but yeah. Okay. So thank you for all that. This has gone on for an hour now, effectively, just over an hour, explaining aspects of the language, aspects of the compiler, and how I've been multi-threading it. And I'm really chuffed to bits about all of this. It's made me really very happy that I have been able to multi-thread it and show all the special timings in here for this. So because I've been talking about this, I actually said there was a second thing, and I'm going to talk about the current progress of the entire Win32 API in Odin. So let's get to that, shall we? Oh, this is going to be exciting. I am just going to remove this for the time being. And okay. Yeah, in the UK, sorry, just my tangent for UK, for linear algebra and calculus, which is different to normal algebra, you do learn that in high school, if you choose to do it, because actually there's something called A levels in the UK, And you may learn a bit of calculus. You might do it at GCSE, and I think some kids are now learning it as well. But you got pretty much taught it at A level, and that's you kind of if you were doing extra maths, like you're doing maths A level or a further maths or physics or something like that, you would actually usually learn a bit of calculus. In physics, you learn basic mechanics, and it's like, oh, you learn how to do differentiation, a very basic integration, and you can derive suvat without not even do the equations, like you can derive where they come from and stuff. Okay, carry on. So this is the Win32 API, and when I say the Win32 API, I mean it all. So how did I generate this? So there's two things I want to bring up, and let me bring them up. So the first, actually, technically the first one is actually, let me just find it. I should have got this prepared a while ago. I can't find it, but let's just talk about it quickly. You don't have to see my case. You can just see my face now. Oh, oops, that was not a good idea to do. Went through it. Oh, it doesn't matter. I'm not showing anything dangerous. You now just saw a bit of spoiler, but it doesn't matter. Camera only. That's what I wanted. Okay. So the first thing I wanted to talk about was Microsoft. So I think about a year ago they did it. Is they allowed you to look and have a format for the Win32. They've been trying to organize it into their metadata files, the Win32 metadata files. And that means you can read it and generate it for your own languages. And So for instance, the whole point is that they wanted different language bindings for the Win32 API. The biggest one they're using at the moment is the Rust. Is the big one. Now I actually had, unfortunately, the file format, even though it's partially documented, it's not really that good. You can't find the stuff that you want to it normally. So I was struggling to do it, and I already gave up after about a week. I really did. I was like, this shouldn't be this difficult to do. Like I wrote the file. It wasn't that difficult. It's a binary file format. Should be okay, whatever was going on. But I was struggling. And luckily, I came across a guy called Johnny Marler. Thank you very much for this. And I've spoken to a lot for this. So let's just go back to the scene. And Johnny Marler created some stuff here. And what he has here is he has a generation file library as well. So this generates the Win32 meta libraries and turns it into JSON. Now, the whole point he was trying to solve here is that he wanted to make it easier so anybody could then read it and generate it for any other language. So I can just download it from this commit, and you have the entire API, which I've already downloaded, in JSON format to read. So let's look at the direct 3D11. Look at the JSON file here. Oh God, it may take a while. Why did I do this? I have it downloaded already. Well, it's a Direct32 JSON here, and it has all of the information that I would want from the Direct32 API. And he's provided in it. And I thank him so much for this because it saved me a bunch of time. It's still not perfect, by the way, not like missing stuff. It's that it's not perfect in that, what's the best way of putting it? There are still things to do. That's a better way of putting it. There are still things to do, which is fine. And I've been trying to correct them in my code as well for generating for Odin. Now he originally did this, and he got it working for the Zig language again. The Zig language, no language out there, and he got the generation working for Zig. Now when I was like, oh wow, it works in Zig, and when I was using it in Zig, it was actually I was like, okay, this is not very fast, and it's because you're importing the entire Win32 API. And in Odin, even when I cut out a lot of the other crap in there, like you don't need the machine learning stuff like DirectML and the new stuff, like, not being rude, I don't want that as part of core, and I don't think there's any reason why I'd want it. But it's a lot of code, and in Odin, it's about 1/3 of a million lines of code, and that's a lot of code. To load those files, they're big files, then you've got 16 megabytes in total, I think, of files I've generated. And 16 megabytes isn't that fast. Like, for instance, if you're reading that raw, it's going to take a while to load. Especially on a hard drive, like I'm actually using a hard drive for all this stuff on purpose when I'm doing it, obviously, because I need to make sure it still works for even slow people. So running it on a hard drive, that's going to be slow. Then you've got the other issue going on, which is what was it? Yeah, so you've got the hard drive for the problem. You're going to have other issues like, okay, loading the files, and you've got to parse it, and then you've got to time check all that. That's just a lot of data, so it goes slow. So I wanted to cut out a lot of crap to do that. The other problem is many people have probably ever dealt with the Win32 API is how cross-dependent it is. So they've tried to organize it, obviously, but again, I'll go back to my video. They've tried to organize it, and that's a try, but some things still depend on it, and there's big cycles. In fact, I have a big graph I made showing the actual cycles of what things depend on what. Let me just find that. So open containing folder. There are two graphs. Let's give it the simple graph. So this was used by Dot. This shows you which their own little API. So an API. This is actually not even technically an API. It's an API category. I made the thing up, but it shows you which depend on what. So foundation depends on nothing. That's great. So foundation is idempotent. It's very basic though. And management only depends on foundation. So okay, it's fine. But then you have things like, okay, network depends on network management, and network management depends on networking. Like, okay. A global viz doesn't depend on anything, but web does depend on it. These independently, you can see where the thing happens now. You have data types, and no, wait, this is just data types. So a data type in this depends on this. And you have a big mess of a graph going on the Win32 stuff. And yeah. So I kept thinking, okay, how am I going to solve this problem? Because I was going to do the graph theory. And to be honest with you, I'm not that clever at graph theory at all. I really wish someone could help me do this. Like, oh, how do I make this better? And just like reorganize everything and try and get everything done there. For instance, removing AI, simplify things, but only a little bit. Gaming you still need because it's not just as gaming, it has other things in there that you want. And I got rid of some other things in here that were sub-related, which were huge. So my idea was okay, I want to organize the types that I can that are in that thing and depend on no other package, or no other package depends on them, and keeping them in there. Making sure there's no cyclic imports going on, because Odin can't have cyclic imports. And anything that does have cross dependencies, we push this into its own little package, which everything else can then import from. And then they all know each other within the file, because everything in a package can see itself. So anything within a package knows where it is. That's fine. Again, we probably don't need the fax machine stuff. We don't need the tape stuff. We don't need the dial-up stuff in there anymore. So there's a lot of stuff we can chuck out. So that's fine. But still, you still have all these cross dependencies going on. The naive approach, which is what I'm doing right now, it's still not fast, unfortunately, but it's not. Sorry, just what the best way of putting it is. It may not be fast, but it's working. Let's just put it that way. Is you put all of the types into one big package, and these look, all of them. Look, that's all of them. Look at a big directory. If you can't see the text, it's big. You can see I'm scrolling a lot, and it's big. So, for instance, all of the types that I've defined are just defined into here, and you can see they're all being defined correctly as well. For instance, here's the D3D10 texture 1D has the procedure calls in there. It has the vtable, and it's using it as a vtable separately. And by the way, it's got the data type there, and then you can use one of Odin's lovely the arrow feature. So this is specifically for the COM API. That's why I added it. You have all the string stuff, the GUID stuff in here. Oh, I've got the camera. Stop. I'm still getting used to this camera. Right, there we go. So now you can see it. We've got all of it, and you can see with the scrolling, this is all of the types in the thing. And if again the text is so small, I'm scrolling a lot. You can see there's a lot of files in there because each file is for a separate thing. And again, it makes type checking faster because you can collect them separately as well. But you've got the problem is now you've got multiple files to load, which is actually then you've got a bandwidth problem with you've got a reading problem from your hard drive, which is slow. But yeah, this is generated the Direct3D10 stuff here, and it's none of it's confidential. This is the Win32 API. Sorry. That you have all in here, and look, it's very stuff. So it has the table, the vtable. You can use the nice little arrow operator, and COM has in the COM. Specifically, I literally added this so you can have COM API. So very careful. What I mean by this is you can do x.y x123 in like normal language, and this just means that says it's a value in here. Well, this is really annoying to type a lot of the time, and when I'm doing con API stuff a lot, you wanted to act like it was actually designed that way. So there's a little feature in Odin that you can do, which is the hour operator. And it's very useful if you've got a vtable and you've already been assigned, you just call it and do it shorthand like that. And it transforms itself to the one above. It's that simple. And because it's that simple, it's very, very useful. It was specifically added for COM API, but it's allowed it. In many senses, this is very similar to Lua's stuff, where you have a binding with a colon. So in that sense, it's kind of that similar, but it's not a method bound to a type anymore. It's just literally it's just a value in a struct. So it's that kind of thing. And yeah, everything's generated. You got all the GUID stuff in here. You got the GUID values. Got everything detailed. Everything's been generated as you'd expect. And yes, you also use it for Hacky Objective-C class messages as well. Yes, thank you, printf Armin. And yeah, it works. But it's nice for those edge cases. Like again, Odin is trying to design things for real practical cases. I'm not trying, and also I didn't want methods in Odin. I'm not against methods. I just think if you're going to have methods, you need to go full head and do what you should be doing. Like you need to add type classes effectively. And I didn't want to go the type class route. So I said, yep, no methods in Odin, never will. That was a big decision I made very, very early on. And I went, yeah, I'm not against methods, be very, very careful. I didn't want to go down that rabbit hole. It's a rabbit hole of a thing. And if I'm going to do it, I want to add certain features to it to make sure that they're useful and not just sugar, effectively. So yeah, that's all generating the types. So then we've generated all the types. There's also a built-in one as well, because there's some built-in types like GUIDs, and any of these aren't even fixed yet because I'm still generating stuff correctly, by the way, if you didn't guess. But some of them have some missing CLR types, which is not part of the code. Yeah, some are missing. And because they're missing, you have to... I'm just going to have to hard code these in. So it means the metadata isn't complete. But, oh well, it's not complete, is it? Someone said, yeah, you're going to have to wait for Odin++ to get methods. Yeah, and that's never going to happen. But it's not because, again, not against methods necessarily inherently, just... I've also found that you don't really need it in Odin. It's quite nicely... I like imperative procedural programming. I like programming in C. And you very rarely need an actual method. And then when you do, you can generate a vtable really easily. Especially now you've got inline procedure expressions already, like lambdas in Odin. So it's really simple to use. And we use lambdas all the time in Imogen for like our vtables, because we do have vtables for certain things. And we just write them in line, because you got the vtable specification. You just make an instantiation of it. You write the stuff in it. Oh look, it acts as if it works normally. So it doesn't actually feel any more restrictive than other languages, and it's not type based. It's now just like table based instead, which is I kind of prefer that approach anyway. So back to the Win32 API stuff. We then have everything else. So for instance, each package has its own little it'll have multiple different APIs within that package. And so you have to be so it has everything, and each API in the package has 3 files associated with it. It has the constants, procedures, and types. Sorry, I'm just burping there. Need a bit of water, that's why. Much better counsel, Bob. And so I've just separated them. It just makes it simple. So you have all the constants here, again, they're untyped, except when they're handled, like in this case here. And that was a hard-coded thing because I want to make sure it worked out correctly, and so on and so forth. We have foundation procedures. So these are we've got the types, which are just aliases. They import the types from there and just literally alias them. It's very simple. And they have the procedures. Now the procedures, this is a very nice thing about Odin. So there are 3 things that are going on here. The first is the foreign imports. The foreign imports are, as you can see here, we're importing the system libraries, and they've all got named, and we're getting their import names here. That's the first thing. The source code is defining what it needs to be linked against. First thing, by an entity name. We then have a foreign block where everything in that block is associated with that thing. Okay? So now this is associated with the import name. And the next thing is we can add these attributes to it saying, hey, we want to say every procedure in here by default has the default calling convention of standard call. We could manually write it and go, oh, standard call. We could do that. But to reduce typing, make it easier to parse, make it easier to read as well, we just say everything is in there. So this, again, they've got the foreign import names, the foreign blocks, and the default calling conventions. And look, everything is separated into these different things. So most of these stuff in the foundation stuff, you may not need all the sys, like sys_alex string. Maybe not, you probably don't need that. But what you probably needed is most of the close handle stuff here. Like, that is probably what you wanted. And the get handle information, set handle information, yeah, it's very useful. We go to another thing like the direct 3D stuff like that. Okay, we've got create type, create devices, create blob, shaders here. Okay, and there's also the other one which is direct 10 1, and look, this is create device 1 and create device swap chain 1, and they just happen to exist apparently, but they're in a slightly different library. Yeah, there's all the different things created in there. We'll look at direct 311 this time. And we have Direct 3D11, we have the Direct 3D compiler 47 in exclamation marks, and then Direct 3D CSX. I can't remember what CSX is. Oh, it's creating the scan stuff, FFTs and everything. Oh, wow, I didn't know that existed actually. Hey, don't you learn this stuff every day? And it has all those procedures in there as well. And again, each of these has generated. Now, you may think, where's all the other ones? Well, you have to create the COM objects to do them, don't you? Which I'll have a utility function to help you do that. Which is easy enough to do. But yeah, there's loads of stuff in here. Like, oh my God, Windows has everything in here, to be honest with you. Really does. Some of it, like management. Do I actually need the management code? I think I could probably get rid of this because like mobile device management. I'm thinking, yeah, we don't need that. Even though it may be useful for some people, I don't think I need it. Networking and such. There's a lot of stuff in here. But look, it's being generated. Now, I've got an all thing in here just to test. This is imports all the packages. Let's do Odin check, shall we? No, it's not Odin check. No, I want Odin check on that directory. I am going to no entry point it because it's going to moan there's no entry point. That's fine. I'm going to show the more timings, and I'm not going to show the debug messages actually. Sorry, I'm just going to get rid of the debug messages. I'm going to run it once. So run it twice, just to get it revved up. So that checked the entirety of it, and that's, I think, 60 megabytes of code. That's about 300,000 lines of code, which is why I needed the show debug messages. The total lines of code here, total lines we get 350,000. 350,000 lines of Odin code. Or another way of putting that, that is 2.5 million tokens. Or another way of putting that is 16 megabytes. Okay, or 807 files. That's a lot. So now we're kind of like file bandwidth. So you can actually look at the code and see what parsing files takes up a lot of time. And that's because I'm loading 807 files and then parsing them. Now, what you may notice is I'm cheating here. I did tell you I cheated for this slide because I've got loads of code. This is a hack in the compiler, but I've done it on purpose. Just in case I couldn't get the compile times fast enough for the Win API. I didn't want to slow down everyone's project and say, oh, look, just fine. The thing is, the collecting entities takes 100 milliseconds. That's still a lot because there's a lot of entities. Like, there's a hell of a lot to check. Like, if there's 300,000 lines of code, there's probably 200,000 entities. Like, there could be that many. Yeah. And then we're collecting it, exporting them. Okay, so that's quite a bit of chunk. The big chunk here is obviously the parsing check files and everything else. So notice, check procedure bodies and all the other stuff is empty, even though there's nothing checking. We checked all entities and it's 4 milliseconds. Wait, what? That can't be correct. Well, if you actually looked at the code, what we were doing, we actually had at the top here, we had a build flag that said for Windows. Yeah, because these are all Windows files, so we don't want any other worrying about this. But secondly, as I put this lazy tag, again, this is the experimental internal thing you should never touch. Very big disclaimer: do not touch this. Do not touch it. But what it says is, yeah, everything in this file, not package, but this in file, don't check it. And if we do, and we ignore the lazy flags, which is what we're going to be doing here, yeah, notice it's still taking compile. It takes about 7 seconds, I think. Normally, so I think it's going to take a little bit longer because we're on stream. Yeah, so there we go. It took 11 seconds on stream. Normally it takes about 7. Yeah. And look at that. Checking all the procedure entries because they're single-threaded. They're not multi-threaded. Yeah, that's 11 that's 10 seconds worth because it's got so much. And that clearly shows you when you have single-threaded things, like here's another thing, okay, that's 60 milliseconds for that was fine. Problem is the single-threaded stuff starts being the bottleneck. Again, if I have a 4-core machine here, so in theory you could cut that by 4. In practice, it goes down to 50%. Doesn't go down to 25%. It goes to 50% of the original time in practice. Not because of slowness or anything like that. It's just because they're not contention. It's more to do with the operating system gets away all the time. So you could probably make it faster. You can probably get down to 25 theoretically, but you don't necessarily. So I'm looking at the ceiling while I'm talking because I normally do that. I'm not looking at the camera very clearly. But yeah, that's probably okay. So that's why I've got the laziness thing in there. If you didn't guess, we go down from 11 milliseconds in compile time. To go down to 400 odd. Again, it's less than 400 on off stream as well. So it's still annoying. My goal is this would be acceptable if this was about 30, I'd say. So I've got to go by another order of magnitude faster to do this, which means I need to cut down code. It's the easiest way of doing it, and also make the compiler faster. And I would say 30 milliseconds is completely acceptable then. I know it's a big library and such, and 30 milliseconds is, I would say, is an okay cost to add for most people. But 400 is not. I do not think 400 is at all a reasonable cost, because you're importing everything, which is why I need someone. I'm going to ask for help. Someone who can help me with the graph theory. I am not that smart. I couldn't figure out how to do the sorting to minimize it. I did one basic sort originally, and it reduced it by 30%. But even then, that's not enough. Hopefully I could reduce it by. If I could reduce it by 90. Oh, that's an order of magnitude there. Can you see what I mean? 90% is an order of magnitude. But it's hard to do. Like so. So that's kind of the progress I've been doing. And you can see I've been generating everything in there. It's really nice. Like, oh, look, there's address book stuff in here. Like, apparently that exists. And where's the fax machine stuff is my question. I remember it. It was on, not networking. No, where is it? Management? No, where is it? Devices, yeah. Yeah, it has all the fax machine stuff in here. Like, look how many fax machine stuff there is. Fax machine constants. There's a lot of them. And a lot of fax machine types. Like, oh God, there's a lot of them. Look. Again, do I need to worry about any of this really anymore if people are using Odin? Especially since I'm not really targeting older stuff anymore. Direct input 8 create there and stuff. Oh, there's a lot of stuff in here. Like, it's amazing how big the Win32 API is and how insane it is at times as well. But yeah. So sorry, I did miss some of the comments. One person said that universal function call syntax is better than methods. I don't think it necessarily is. I understand why people like it. Odin will never have it, mainly because Odin hasn't methods. So what's universal about it? All function calls are identical in how they call them. So that's already universal, duh. But what they mean is you can use a function call as if it was like a normal standalone procedure or if it's a method. A good example of this language would be Nim. The Nim language does this. Nim gets away with it because of how it does its package systems and scoping systems. Odin couldn't do this, so it doesn't actually make any sense. If that is clear. Hopefully. Okay? Yeah, dlang is another one that does it, not to the same extent, but yeah, it does do it, yeah. There's a few other languages that do it. I cannot remember them all. But yeah. Okay. Hopefully that is hunky-dory, as I keep saying that word. I love that word, hunky-dory or chili-pokery. But yeah, that's the progress that I've been talking about for the entire Win32 API in Odin. It is still not ready yet. I'm not going to release it to the public. I need to get it down by another order of magnitude. I need it to effectively do 90% less work. Like, if it can do 90% less work, oh, so much better. In fact, if it does 90% less work, it might not just be 90% faster. It could be like a lot faster, in fact, because it adds up and up as you do it. So, hopefully this has been an interesting stream. I'm not finishing yet, but I'm finishing in less than 15 minutes because it's late and I probably want to go to sleep. But yep, let's get rid of that. And yeah, I'm pretty happy. So to briefly cover what I've been talking about today is I've been talking about how the Odin compiler's front end has been multi-threaded. There are still bits I could improve, of course, with that multi-threading and make it even faster for certain stages as well. I'm not doing that yet, but there is no reason why I theoretically couldn't. I also just wanted to make sure each stage was separate when I could do things from a kind of a language design standpoint. We talked about which bits can be multi-threaded, which bits cannot be multi-threaded, must be serialized and keep in a single thread. I've also now talked about the new Win32 API stuff, so we go to this. And yeah, there's many big cool stuff that's been in Odin recently. So again, hopefully, if you've got any more questions about stuff, please ask them now. You can ask them as many time. So thank you all for watching. Seriously, this has been quite fun. Yeah, the autofocus is still a bit annoying, and I'm just going to disable it, or just get a fixed focus lens. It's not this powered zoom lens. Oh god, it's actually really fast at tracking autofocus, but it likes, because I keep moving a bit, it's tracking other things and it goes. I can just about see it on the monitor. I'm looking above if you can guess, because there's a monitor above it. I might just get rid of that. I should have done that at the beginning. Now I can't look at it. I can only look at the actual thing itself. So now it looks like I'm directly looking at the thing. So, has anybody got any good questions? Or any questions? Even bad ones. You can always have the bad ones as well. This is a Sony camera. This is the A6400. So yes, they do have an excellent face detection apparently, but they're still having this jitter for some reason. I don't know if it's because of the lens, because of the camera. Both are second hand. I doubt it's that. I think it's probably that. No, this is the latest generation. This is the A6400. It's the latest generation. Yeah, there's probably a photo setting tweak. I probably need to disable it. Again, I'm still learning the camera. Oh god, new cameras you could learn for a long, long time. There's a lot to learn out of them. So an off-topic question. So maybe read on Zipf's law and infinite mouse targets at screen edge. Your taskbar placement is suboptimal. No, it's not. I have no idea why you think my taskbar placement is suboptimal. I've been using this for over a decade. I know it's more optimal than the approach. The reason why it's more optimal for me is because I can just look at the top, more likely, because that's where my eyes are with relation to my screen. So that's ergonomics. I just look to the top and I can see the numbers. I can see what's open and I look down. If it was at the bottom, it's actually worse to read in that regard. And as Zipf's law that's not a reason to invoke it. I know how my own eyes work. And yeah, there's all this empirical mass density search. And I'm like, yes, I'm at the top. I'm not at the bottom. So this is a good place to put it for me. Many people disagree, but yeah. Yeah, there's probably a switch I need to change on the camera. I don't know. Yeah, I'm still figuring it out. So yeah, and I'm looking here and I'm like, I look down, see what there is. I don't see, like, I'd have to look at the bottom because I'm moving my eyes at the time. I'm looking at the top most of the time. So I don't know why you'd think it's suboptimal. And it is at the screen edge. Look, screen edge. What are you talking about? I can go, whoop, it's there. Or whoop, that's there. I'm not considering tabs in browsers. These have got tabs in things, and I go to the edge and it's like, oh, I have to go back down again. So I don't see I know what you're saying. I mean, even tabs in browsers are not that. I don't usually click them. I literally use the shortcuts most of the time. I hardly use a mouse. Look. So, yeah. when I'm swapping a tab, I go. You can't see what I'm doing. I just realized I'm on the screen. So yeah. So by the way, I was doing here is I'm at the top. It's very easy. You can see it at the top of the screen here, and it's fine. And look, the tabs, there's a gap between here anyway. So I don't click it, and I just go. Go here and go. So I don't use the mouse that much for most of that stuff. So again, you keep telling me stuff that is wrong. I know how my workflow works. Don't invoke a law when it doesn't apply. Okay? Okay, any other questions? Off topic, do you believe in test-driven development? Well, I believe it exists. Okay. As in, okay, I'm going to answer the real question. So I have actually done test-driven development before for a job. And it means you're writing the tests for your development and basing your stuff around those tests. That is actually not a bad thing if you've got a lot of integration, which is what I was working on, integrating different things, and you knew how it should have to work because it was already predefined and doing it that way around. But for anything other than that, I don't think it's necessarily a good idea. It's a very specific use case. Like if you're doing stuff that needs, you have a well-defined test already, like it's a very well-defined environment, you're writing the code, not for the test, but like you're just writing code effectively. So test-driven development is not necessarily any unique. It's just a very specific, you're just saying it's what code is in a specific use case. I very rarely, I have usually more windows open than tabs. I'm not a big fan of tabs, to be honest with you. They really annoy me, and I usually close them all the time or have multiple windows open. Yeah, I'm a bit old-fashioned in that case. So yeah, sorry about embark out. I was just saying, like, yeah, it's not bad placement because I just go and it's easier for me to read. I understand why many people like it at the bottom. I really do, but to me, it's just like, also that just shows you how there's something gone wrong there. I don't like it at the bottom because I have to crick my head and I've got big monitors, and also I've been using it at the top for like a decade, so it works for me. Okay. What were the other questions that other people had? Anything I actually missed? I'm just checking. Some people about schooling systems. Past that. UIs. Yeah, okay, I didn't miss anything. That's good. Okay, I'm going to stay on for another 5 minutes, and then I'm going to go to bed. Because it'll be midnight. I know for some people it's probably early, not. Yeah. Fortunately, Windows 11 forces the bottom, at least for now. Yeah, I know. Because Windows 11 has some brilliant design decisions in it. No, it doesn't. No, oh god, I don't. Oh, I'm probably not going to update for a long while. Yeah. Yeah, if someone says people have the taskbar at the side because you rarely use it. Like when I'm using like OS X or something, sorry, Mac OS now, because it's technically not X, it's not 10 anymore, it's 11. I don't know, whatever, Mac OS, what's called it, Mac. Well, I'm using a Mac for once, right next to me, right here. I usually have the dock on the side because I very rarely need it, because I usually just need to see like, okay, click, and it hides away. I don't like hiding the taskbar away in Windows because it's actually crap. It doesn't really work very well. And I am also using Start is Back to get all this nice little functionality here. And like, oh, look at that. I love this functionality. Sorry. That's something you could get back in the old days. Windows 11 is, yeah, but yeah, so for ergonomics wise, I think every people's different. You get used to different things, also different works. Some people are very mouse heavy, and some people are not. Tabs are also a very new thing in like, I've been using computers before tabs really existed, so I'm used to using Windows, and I'm also used to all the keyboard shortcuts as well. So I'm a kind of a heavy power user. I'm not the average person. So yeah, it's very weird things you get used to. They have probably improved some a lot. Like a lot of the UI problems, they've also now, everything seems to be a web browser for the UI in Windows. Not a joke. Everything is a web browser. Just. I know why it's gone there. It's mostly the structure and the size of things. It's just easier to do everything as a web browser because everyone knows CSS, but not everyone knows C or just write them like, just Not going to rant on that. Yeah, it was just not rant on that. But yeah. Let's go back to my camera. Like that. Yeah, there we go. Windows 7 UI was perfect, someone was saying. Everything about that is awful. It's basically a search for the hidden old interface at this point. Yeah, it is. Windows 7 was not bad. I updated. I went to Windows 8.1 for a long time. I didn't update for 10 for about 2 or 3 years, I think it was. I kept on 8.1 for a long time. The reason being is that I had Start Is Back. Start Back is a nice little tool. I know those are the free versions, but Start Is Back has always worked well for me. And it was always very cheap, and I had to buy it once. And Windows 8.1 was fine. I didn't want to upgrade to 10 yet. I'm really kind of wait. Sometimes a very early adopter of many things, and then some things I'm not. Operating systems is not necessary, unless it's this is the thing is Mac. It was always easy to update, but Windows wasn't. So, whatever. But yeah, and Windows 10 was mostly fine. Windows 7 was mostly fine. And again, I understand why they want to update it and improve it, make it more fashionable, follow all the trends. But it was functional. There's not really any much issue with it. You've got the Windows 10 beta, open beta period before release, and you ran Windows 8 for not very long and you hated it, yeah. 8 was bad. 8.1 was good. So 8.1 removed a lot of the Metro crap, or whatever they renamed Metro to. Like they named it something else after that. And again, with Start Is Back and literally deleting all the Metro stuff, it was fine. You'd wish they'd make up their mind about the settings versus the control panel, preferably in favor of the control panel. Yeah, the control panel was better still. It's still better than the settings. The settings is just huge, is the first thing. It's not easy to find things. The search panel doesn't rework. Oh, it's all bad. But yeah, I know this is clearly none of this is Odin related now, by the way, if you didn't guess. This is kind of completely we've gone derailed. I don't know where we're heading off to, but yeah. But it's in fact it's Fitts law, not Zipf's law. Yeah, I know what you meant. So we're just Fitts law. Zipf's law is it's empirical stuff. That's what you mean, yeah. So Fitts law. It's the distance to target. You want to make it sure it's big and easy, yeah. And I understand what you're saying, but it's like your arguments weren't making any sense because I don't use the mouse for that sort of stuff. So, yeah. Another thing was, I think they're trying to move everything to new settings, but they are taking billions. Yeah, but they just create a new thing and they have to keep the old thing for legacy reasons, so they'll never get rid of it. What would be Bill's law or Odin's law? Ooh, now that's a good question. Odin's law, if it's the language, of course, not the god, would it be just things just work, maybe, or try to be? Try the law. That's the law I'm trying to aim for, at least. Is things just work. And that's a high goal, of course, because things just work need to be magic. And this is not necessarily magic. But I don't know what Bill's law is. Most commits will be typos. Fixes. That's what my law is. Most commits are typo fixes. I think most people will agree with me for there. In Odin, most are typo fixes. I make a lot of typos. And most of my bugs are typos as well. It's probably the reason why, for me, like in dynamic languages, I want the static type checking. I don't want lazy type checking. I want it static because I make a lot of typos. Right, what else is there? Any other questions? I'm going to go away in a few minutes. So get your last questions in. I'm going to ring the bell. Oh, that's not really a bell. It's a glass. Close enough. It's last call, last orders. For every fix commit, there shall be an equal and opposite pair of typo commits. And usually it says fix typo, so yes, that's correct. That is probably a good law, I would say, yeah. What are the current compile times? What do you mean? For compiling Odin itself or compiling programs in Odin? Again, a very specific question someone's asking, which is the SZCSYGI __ What are current compile times? So in Odin itself, so not the compiler. So Odin, I was explaining here, is they are pretty getting fast now. So there are different aspects to Odin, and I'm just going to show you more timings in general. This is going to run it twice, just make speed things up. Generally, so I think parts. Okay, this is doing the demo. Demo Odin. It's not a small, just a big enough demo. It shows enough like a general project. It uses a lot of the core library as well to show what things are happening as well. So this is parsing takes 4.5%. Type checking takes 16%. LLVM takes 53%, and MSVC takes 24%. So 26%. So 75%. Oh, it doesn't matter. You can't see. I keep doing this. I'm not used to using the camera. This is again first camera I've seen on stream. I'm just trialing it out. Okay, so these are the compile times for doing build. It's just the demo, and I'm just building it all entirely. And you can see here we have 550 milliseconds in total, of which 25 milliseconds is parsing the files, 88 milliseconds is for type checking, 292 is for LLVM, and 143 are for the linker. So it does get a little bit faster with LLD, but it's not actually it's because it does only get slightly faster. There's not many object files it's actually linking against. I think it's only linking against like 3 in total in that thing, 3 or 4. So it's not necessarily can benefit much more what LD does. But in fact, yeah, improving the linker would be always a good thing. Changing to another linker. I hope like the mold linker, which is a new thing. That's the guy even designed the original LD one. If the mold linker, which is highly multi-threaded, if he could get that working with cough symbols, not just elf symbols, I will be, oh god damn, I was so happy, so happy. And I don't think there's anything inherent about the design of it which would prevent it from doing it for cough, but yeah. But so as you can tell, so Odin's compile times, the actual language itself is very fast. The slow part, the compilers are very fast. This is, again, the whole point of like Odin was to try to design it to be a fast language. Like there is nothing really inherently slow about Odin, except for the things we discussed earlier. But as you can tell, LLVM is a big bottleneck. 50%. So over 75% of the entire compile time is now dominated by stuff that's out of my hands. In fact, I could probably reduce this down slightly as well. We're using the use separate modules flag, which is experimental, by the way. So we would cut this down by 100, and now we've reduced this down. So now this is 75% still, but now more linker is now in the linker stage, and it's balanced it a little bit. So you've just shoved some of the work from LLVM and put it onto the linker, effectively. But yeah, it's just in general, which is not the experimental feature, by the way. Yeah, most of your time is now going to be taken up. Oh look, this is now 82% is taken up by the thing. Yeah, that's 80%. So 80% is out of control, unfortunately. That shows you how slow LLVM is. Is it an option to write your own linker, or is it generally not worth doing? Yeah, you could write your own linker, but people are already doing that. I don't really see like making my own just for the sake of it. Like, I don't see any reason why I would need to. I'm somewhat natively hoping that the Steam Deck manages to move the needle away from Windows. Yeah, so I'm really excited for the Steam Deck. For people who don't know me don't know me exactly, because it's probably most people. Let me just wait a second. And I'm back. That was a very quick second, obviously. This is one of my favorite controllers. Yes, I still have the Steam controller, and I use this to play up most of my games. I am a massive fan of the Steam controller. You can probably tell how much of it. There was grips on this. This is now completely buttery smooth, and it's one of the most comfortable controllers I have ever used, the most highly customizable, and it works on any game I've ever used it. Any game that doesn't even have controller support. I have played the entire Mass Effect 1 and 2 on the PC, which the original ones, by the way, not the new Unlimited Ultimate Editions, whatever, didn't have any controller support unless you modded it in. And I played them fine. I've played Counter-Strike on this absolutely fine. I've played, and I was doing fine because the gyroscope, the trackpads, oh my god, they are better than the controller. And you can just lie back. The battery life on it is brilliant. You usually get about 80 hours of battery life on just normal AA's. But yeah. So the reason why I'm excited for the Steam Deck is that the controls on it are pretty much an evolution of this. And I'm also really excited because of what Valve has done with Proton, which is their fork of Wine. And for people who don't know, Wine is Windows in Nix emulator or environment or whatever it is. And it's effectively emulating all of the Win32 cores that are possibly used. And that is really, really exciting. And from what they've telling, it said, on our system with our new latest branch, all the games that we have tried seem to work. And they haven't found a game that hasn't worked yet. And that's on that device. Oh, wow. Does that, Wine is not an emulator. Okay, so I couldn't remember what Wine stood for, whatever. Even though I've been using it for years, I forget initialisms. They're hard to remember. No, it's not. It's an acronym in that case. It is an acronym. But yeah, it's. I'm excited for the Steam Deck for two things. One, it gives me a portable PC effectively. I have now got a way of playing the games, which also has controls for any games with like Steam-like input, and Steam input is very good as well, very highly customizable. I could just take another controller like this and customize it for any game that even doesn't have it, and like, oh, that's good. So again, Steam controller better than the Xbox controller in my setup personal. I could even use a GameCube controller, which I have right next to me as well. I mean, I have loads of controllers. How much has Steam paid you? None at all. But no, this is a dead product. This is dead. I even have a spare behind me just in case this dies. I've never opened it, and just in case that dies. And if it dies and that one's faulty, I'm going to be a very sad day. But no, it's one of those where I know why this failed, and it had nothing to do with the controller. It had all to do with Valve didn't explain anything to anybody, and all of the reviewers don't know what they're talking about. They picked it up for 5. I'm not joking. Like, they went pretty much for 10 minutes. And went, I don't understand it. It's a very different control layout. I don't understand it. It's crap. And then just talk about that. It's like, then they were talking about, the controls aren't that good. They're all not all good. I'm like, did you not mention the gyro? I'm like, what's the gyro? I'm like, the best feature in it. And like the modern controllers now have gyros as well, but Steam controller was one of the first. But some people had better controllers. Like some people love it to this day. I'm still a Steam controller fan. It's the most ergonomic, the comfiest, and the most adaptive controller you could possibly get. Sorry, that's me. That is me. Shilling Steam controller, a dead product you can never buy anymore. So there you go. Sorry, let's get to some of the other stuff that people talked about. But yeah, so I'm excited for the Steam Deck, yeah. And I hope it does push away from Windows. But yeah, to a certain extent. It also shows you how good they've worked on Proton. Yeah. I have a lot of criticisms of Valve as well, by the way. A lot of criticisms of Valve. But in general, yeah, the Steam controller, it was too early. It really was too early. And the Valve is awful at their damn advertisement. They don't do any. And they don't explain things to their customers or anything like that. Oh, God, it's bad. They're getting better now, luckily. Like, for instance, the Steam Deck, they partnered with IGN, didn't they? To advertise it. And I think they've learned the lesson. They need to tell people everything about it. And then there was all of the reviewers saying, who took the misunderstanding that 30 FPS minimum standard was everything. It's like, games only run at 30 FPS. It's like, no, that's not what they said, you morons. Now, sometimes you have to think they're just saying that on purpose to get more views, because that's what people do, don't they? But yeah, it's a weird game, isn't it? So I've been speaking for quite a while now. I could have gone off this screen and back to the camera only. So now you see my beautiful face, my luscious ginger beard, and yeah. Yeah, I need to change that autofocus because it's really just jarring. That's not good. I need to play around this camera a bit more. I've been doing holiday snaps on it and everything, and it's great. I love it. It's a brilliant camera. I love it. How long will you grow this beard? About this long. I have had it longer than this before. I've gone about here. No, I either look like an Orthodox priest is one thing I could say. If I have my glasses on as well, it looks a bit like that. Some other things I will not say on camera ever or in public. I don't look good with a big beard. I start looking like... It feels like Zack Snyder is editing your stream in real time. No. If it was real time, you would need to a 4:3 aspect ratio is what you need. Actually, I do like some Zack Snyder. I do like the Watchmen film, actually. I'm a big fan of Watchmen, the actual book, which you can probably see on my shelf behind me. I'm a big Ant-Man fan. And it's actually one of the only films I can think of which is pretty much scene for scene identical to the book, except for the ending. And this is going to sound blasphemous for some people. I think the Watchmen ending in the film is better than the book. I think it's a lot better. I don't want to spoil it, what the endings are, of course. If you've never watched it, it's very good. But I know some people prefer like I'm like, yeah, but other than the ending, I'm like, yeah, I think that's it. But yeah, it's a very good book. It's a very good book about, it's effectively, people don't know what Watchmen is. It's, the actual themes in the book are kind of hidden. It's aspects of Batman. It's aspects of meta-ethics. Every single character is embodying a different meta-ethical view. And what's the other aspect of it? It's also about, it's about ethics in general, apparently. It's a very kind of thinky book, if you don't realise it. Because if you just read it, if it was a normal like graphic novel, you wouldn't notice. But it is very good. I do like Alan Moore stuff in that case. So I think that's calling that a night, shall we? No more shilling the Steam controller, a dead product you can't buy anymore, which I bought when it first came out. And yeah, I do enjoy it a lot. I cannot wait for the Steam Deck when that comes out. Hopefully that is a good product, and hopefully that's successful. So actually only up to Valve to decide if that's successful, to be honest with you. So thank you all for watching. If you've got any more questions, please join us on the Odin Discord. Odin Discord is one of the best places where you can come to find out some of the cool stuff. And it's a lovely community. If you've got any questions, people are always free to ask. There's always someone online usually. If it's not me, it'll be definitely somebody else. So have fun, and also try out Odin if you haven't tried it before. Odin, go to odinlang.org and do it. Thank you very much, and it's now end of Thursday. It's now Thursday, not Odin's Day anymore. Oh, son of Odin. And good night.